Kia ora koutou. In this video, I'm going to do some graphing questions from last year's Wellington College Year 11 exam paper. And in this video, I'm just going to focus on 4 questions that are what we'd consider basic skills for Year 11s. So here are the 4 questions that I'm going to do quickly. The first one is sketching a linear graph, y equals negative 3x minus 1. The next one is sketching a parabola or quadratic graph. The third one is sketching an exponential graph. And then the fourth question in here is to go backwards and work out the equation of this graph in here. I'll do another video later with some harder problems in it, and I'll have a few more of those coming out over the next week. So let's go back and look at that first one. With each of these, I want you to pause the video and give the question a go before I go through it, and then watch me do it. I'll try and do some nice neat graphs. So by the time we get to year 11, we'd like it if when you see this equation or function that you straight away recognize that it's a linear graph, right? Its highest power in it is an x. There's no x squareds or anything. And we notice that this is my y-intercept and that this is my gradient. And that tells me how to graph it, right? So I'm going to go straight to the y-intercept, which is at -1. I'll put a point there. The gradient is -3, which we can write as -3 over 1. That means that I can go out 1 and then down 3 to here. If I want to, I could do that again to get a second point, but I only really need 2 points. Then I get my ruler and I carefully join those points up. There we go. Okay, so that's it. Oh, it's nice also to label it. So y equals -3x minus 1. If you did have a brain freeze and you were sitting in an assessment and you had to do that, you could use a table of values as well, right? And so that method is always a good one to go back to. We've got x here and we've got y here. We can put in any values that we want, and we'd get out -1, -4, and -7. Okay, let's look at the next one. So this one takes a little bit more time, partly because there are a couple of options for how we go ahead with it. We've got y equals x minus 1 times x plus 3. So the first thing that I notice in here is it's in factorized form. Remember that for a parabola, there are 3 ways to write the equation. There's expanded form, which gives me the y-intercept. There's factorized form or roots form, and then there's vertex form. And we'll come to that one in the next couple of minutes when we have to go backwards. But for this one, because I'm given it in this form, I can see that when x equals 1 and when x is equal to -3, that either of those values will make y equal to 0. That gives me my first 2 points that I can plot. Okay, so I can put on at 1 and at -3, I'm on the curve. Now, next thing I'm going to do here is I'm going to use symmetry of the graph to know that the vertex will be halfway in between. Halfway in between those 2 values is going to be at x equals -1. So I'm going to take that x value and I'm going to substitute it in here to get the coordinates for the graph. So we get y equals, so my equation is this. Now I'm going to take my x value and work out what I get. So -1 minus 1 times -1 plus 3 gives me -2 times 2, which gives me -4. So the vertex is at -1 and -4. We can plonk that on the graph now. Here it is. Now, there are a few ways to actually get going on drawing that curve now. We could do a table of values if we want to. So here's x, and here's y, x minus 1 times x plus 3. And I've got, what have I got in there? I've got -1. We could do -2, -1, 0, 1, and so on. And we can see that if we substitute in -2, we get -3 times -2 plus 3, which gives me -3. We've already got this one. This will give me 0 minus 1 times 0 plus 3, which gives me -3, and this gives me 0. So plotting those, we can see we get a point here, and we get a point here. Now, it's really good to be confident with using a table of values, because sometimes it comes in handy and it gets you out of a mess. But in this case, we could have done it using the pattern that we know. So we've got y equals this, and that's a pattern where it's an x squared plus blah, blah, blah. Oops, x squared plus 2x minus 3. Because it's an x squared pattern, that tells me that the shape is going to be out 1, up 1, out 1, up 3, just like we've done in class with our hands, lots and lots. And that's all I really need to do to draw that graph. I don't have to show a table of values, but it's you can if you want to. So I'm going to try and draw this with a big swoosh. I'll redo it if I make a big mess. Let's see. Oh, stylus is shaking. That's a terrible graph. Let's try that again. Too wobbly. Okay, I'll try it again. I think you guys are much better at doing this with a smooth hand than me there. That looks a little bit better. It kind of goes through there. Okay, now that looks bad because it's not taking up very much of the grid, and it really should. So we're going to go 2, 5, and then we're going to go up to, what's next? 3. So when we put in 3 minus 1 times 3 plus 3, we get 12, which will be kind of off the grid here. Okay. I'm feeling really silly about doing this so badly in a maths video, but hey, never mind. Let's see on the other side, what do we got? -4, we're going to be up here. Definitely a good idea to do this in pencil, guys. Right, there about. That'll do. That's the worst looking parabola I've ever drawn, I think. Never mind, let's move on. Right, the next graph is an exponential, a little bit easier to draw in some ways. So we've got y is equal to 2 to the x minus 3. So looking at this one, we know that my basic exponential shape is like that. And that explains what the 2 to the x is going to look like, but it's been shifted down 3 units. And if you're in my class this year with Mr. Hawke, you know that we've practiced this lots and lots. We can see that this graph is going to have an asymptote at y equals -3. And that's the first thing that I would probably draw in. I'll talk in a second about why it's going to have that asymptote. But let's just get a nice dotty line in here. There we go. So the reason that this graph is never going to reach -3 is that if I just look at the 2 to the x part, 2 to the power of anything has got to be a positive number. It can never get to 0, right? So when I take 3 off it, I can't get to -3. So from here, it probably is a good idea to do a table of values to get the other points, even though lots of you will know the basic pattern, because 2 to the x is the most basic of all the exponentials. So here's x, and here's 2 to the power of x, take away 3. Let's start with 0. 2 to the power of 0 is 1, take away 3. So it's at -2. Okay, so the y value will be -2. At x equals 1, we get 2 take away 3, which is -1. And at x equals 2, we get 4 take away 3, which is 1. And at x equals 3, we're up to 8 take away 3, which is equal to 5. And you can see this pattern coming in here with the powers of 2. So let's get those points on. 0 goes to -2, 1 goes to -1, 2 goes up to 1. So you can see the swoosh starting to happen, and then we're up to 5 by here. And at these values back here, 2 to the -1 minus 3, well, 2 to the -1 is 1/2. So 1/2 minus 3 is -2.5. So you can see we're very quickly getting close to that asymptote, but we are not quite there. So just let's draw that like that, and then up we go like that. Now, what about 2 to the 4? 16 take away 3 will be at 13. Yeah, that graph is also looking like I've got stylus shake. Never mind. I think that graph's a little bit better than the quadratic one. So that's how we do the graph for an exponential, right? We use the features of the graph again. Notice in here that it was just 2 to the x. It didn't have any horizontal shift going on. So it was a pretty clean one to draw. Now, in the next one, we're going to go backwards from a quadratic, and we have to work out the equation of the graph. So to do this, it's really good to be confident with working with the 3 different versions of a quadratic. So let's write them down again. We've got ax squared plus bx plus c. That's the one we first see when we're doing quadratics. For example, 3x squared plus 5x plus 17. The only thing that that one really gives me is the y-intercept, right, which here would be 17. Okay. Then the next one that we've already seen in this video is vertex form. Now, vertex form is really nice if you've got 2 obvious integer values for the x-intercept. But you can see in here, the x-intercept is not looking like it's crossing at exactly 1, 2, 3, 4. So we don't want to use that one. That means that we're going to use vertex form, which is the one that you guys usually take the longest to get confident with. And it's the one that looks like this. So how does this work? Well, if we know that the vertex, for example, suppose we have y is equal to x minus 5 squared plus 16. This has nothing to do with that graph, right? Let's just look at an example here to start with. This tells me that the vertex will be when x equals 5. I know from looking at this one that it's going to be an up the right way parabola, and the lowest that this can ever be, this x minus 5 thing can ever be, is going to be 0 when I square it, right? Because even if I put a negative number in here, when I take that negative number and I square it, I'm going to get a positive number. So at x equals 5, this thing will be 0, and the y value will be the leftover bit, which is 16. So that's going to help me a lot for figuring out the equation in here. The only thing we're going to have to watch is whether there is a scale factor. Okay, but we'll get to that in a second. So the first thing we can say here is the vertex is at the point 3, 3. So it's going to be y is equal to something, some scale factor, and then it will be x minus 3 squared plus 3. Now, we know there's got to be a scale factor because this is an upside down parabola, so we know that a is going to be negative, but it might also have been stretched inwards or outwards. To figure out that stretchy scale factor, we're going to use another point, and the point here is 0, negative 6. So we know that negative 6 is on the curve for y when the x is 0. So negative 6 is equal to a times 0 minus 3 squared plus 3. So negative 6 is equal to 9a plus 3. That gives me negative 9 is equal to 9a. And I'm getting an a of negative 1. So it hasn't been stretched, but it is upside down. Now let's have a look and see if that works. That's giving me for the equation y is equal to negative x minus 3 squared plus 3. Right, now let's just try it out and see how I could have got that a of negative 1 more easily. Here I am at the vertex. Let's see what happens when I go out 1. Well, when I go out 1 here, I'm going down 1 here, right? And when I go out 1 here from 4 to 5, I'm going down 3 here. So just from using the graph, hang on, is that right? I don't know if that's right. Out 1, yep. Down 3, that's better. Yep, down 3 to there, right? And then I go out 1 here, and I go down 5 to negative 6. Okay, and the same thing on the other side. Out 1, down 1, out 1, down 3, and then out 1, down 5. So I could have done that without the algebra. I could have confidently said that there isn't a scale factor except that it's negative. Okay, so that's all I'm going to do in this video. I think that's quite a lot. I think some of you will probably need to do quite a bit of practice on vertex form, and I will set you some Dr. Frost work on that. Thanks for watching, and email me if you've got any questions about what's been covered in here.